Okay, so good morning. So this video is actually about LCDs. So I used to have one of the recordings for this one, but apparently it's not here anymore. Okay, so let's just move on and go to this one. So most of the common LCDs that we see today are these ones. Ito mga to. They're actually based on an older Japanese created large-scale integration circuit. The owner of the IP is Hitachi. So they named it 44780 LCD controllers. Now, these things have actually two types of ROM. There is a ROM for the Japanese English edition, meaning to say uh, letters in terms of the English alphabet, and then it follows that. That's another thing. Okay. So it follows that another Japanese uh, katakana, okay, and English characters belong to that particular ROM. Okay. So it's the character assignment. Another one, which is the 01 edition, is English letters, meaning to say standard alphabet that we use, Cyrillic, Greek letters, and Latin letters. Okay. So 01 is more attuned for use in the European systems. Okay. So European languages kasi are based on those character sets. Okay. And Japanese font, European standard font. So dalawa yung type ng ROM niya. Okay. So this is the standard circuitry for this system. As you can see, there is actually a microprocessor embedded into it. Okay. So the microprocessor is intended to manage the input and output signals as well as the mode signaling for the system. Now, there are pre-generated characters that are stored inside the system. So those are just referenced and taken and placed into the output systems towards the segment, the signal driver, and the common signal driver. Ito yung parang common dun sa ano natin, sa 7 segment natin. Ito yung bits natin A papuntang G, kumbaga, dun sa kabila. But in this case, it's segment 1 to segment 40, yung kaya niya i-control. So, basically, yung controller for the LCD is actually just going to be plainly a processor that was pre-programmed. Okay. So, ito yung mas common na implementation type na ginagamit. Now, signaling natin comes from, well, we have the following. RS, which is basically mode, operation mode. Meron siyang instruction mode, meron siyang data register mode. Okay. So yung instruction mode is used to configure the system. Pagka naka-zero siya, you're configuring the system. Read-write, on the other hand, determines whether you're writing to or reading from the LCD. This changes kasi the position of this one, yung output or input natin. Pagka nakaset siya sa zero, is basically taking in commands. Tama ba? Okay. Taking in commands from outside, bring it into the controller. Pagka 1 naman siya, it's pushing out commands dun sa system. Okay? So you're just basically changing the directionality of the buffers pagdating dito, dito sa buffers na to. Tapos yung E natin, this is called enable. Pero truth be told, this is what we call as the clock. So yung signaling siya. I think this one is lagging edge or falling edge triggered yung device. Mamaya we'll see with the simulator. Now, we have two modes para dito. We have the 8-bit mode, we have the 4-bit mode. Okay. So, yung 4-bit mode uses DB0 to DB3. Sorry, tama ba? I think uh, ito siya, baliktad. DB4 to DB7 kapag nagpapadala ka ng data. Tapos kung 8-bit mode, DB0 to DB7 naman yung ginagamit. Now, all the other items here, hindi na siya gaano kasama. Okay? Except for the supply natin. Kasi module na to eh. Okay? Tapos ito yung ano niya, character development. Okay. So that's not what we're after. What we're after is the configuration system. Okay. Maybe it's faster to do it the other way around. Okay. LCD simulator. So this LCD simulator has been around since 1999 if I'm not mistaken. Okay. But hindi dito sa site na to. There's another site that does it. Okay. So when you turn on your LCD, it basically looks like this. Pag minsan nga wala pa yung bar dyan eh. Okay. So what do? You set it to instruction mode and you set up the LCD. The first thing that you need to do is you need to clear the LCD. So clearing natin is 0, 1 yung clearing. Okay. So notepad na lang natin to para matulin-tulin. No, sorry. Clear LCD. Okay. Port B equals to 0x 01. Clear LCD. So this is 8-bit mode muna. Bago natin mamaya tingnan yung 4-bit mode. Okay. So, para pumasok siya, i-high natin, i-low natin. Doon lang siya nagkakaroon on the falling edge natin. So, clear display. Next, dun sa kailangan natin gawin. After you clear the display, you need to set to home. Okay. So, port B becomes equal to 0x0. Ano yung value? Okay. Ang alam kong home, ayun. Set home. 2. So, ano mangyayari dyan? The cursor will fall to here kapag sinet natin siya to home. Okay. So, each time, kailangan ka mag-administer ng clock pulse. Okay. Sabihin natin call i-clock. Sorry, napapagdikit-dikit lahat ng process. Okay. So, void i-clock. Lalagay lang natin dito. Okay. Port A. Ito yung void main natin. Okay. So, balik tayo dun sa ano. So, ano next? You need a delay of 4 milliseconds in between. So, this allows the processor to actually finish the operations before anything else. Kasi sometimes it takes a significant amount of time para ma-process yung command. So, by default, the datasheet actually lists it at 4 milliseconds. So, 4 lang to. So, next, we need to select uh, the operation mode. So, 8-bit naman to in this case. Pero we need to also select kung 2-bit, sorry, 2-line o single line lang siya. So, to do that, okay, ayan o. Ito, yan. Okay. So, this is 4-bit mode. 8-bit mode yan. Tapos, 2 lines ang gagamitin natin. Pag in-enable nyo to, kikita nyo yung kakaroon nun. So, the next one would be port B, 0x, 0, sorry, 3, 8. Set to 8-bit mode, 2 lines. Tapos maglalagay ulit tayo ng mandatory na 4 millisecond delay. Next. So once tapos na tayo dyan, pwede natin siyang i-turn on. Okay, to turn it on, yung 8 yung gagamitin natin on display. Okay. Okay. So seemingly wala ka nakita, pero actually nag-on yan. So para makita mo na actually nag-on siya, lagyan mo ng cursor. Okay. So in this case, ano yung susunod? Port B is equal to 0x 8 4 to 12B na yun. Plus 2, 14 CD 0D set to uh, display on and 2 lines. Sorry. Cursor on. So once na naset na natin yan, naka ano na siya. This LCD is already something that can already write an item. So, doon na tayo sa do while ngayon. Okay. So, anong gagawin natin? We need to set the value of port A to so may nakalimutan ako dito. Port A, just to be sure, has to be set to 00. RS instruction mode, RW light mode. Tapos, kailangan natin iset yung trish niya, trish A, to 0x00. Trish B, 0x01. Okay, so port A, 0, okay, para kailangan natin baguhin to. Okay. So port A equals to port A plus 1. So lagyan natin ng delay MS for milliseconds. Tapos port A minus 1. Pwede na pala natin tanggalin to kung doon natin siya isasaksak. Tapos dito, port A, 0, 2, 0x02. Kasi yung the significant bit mo is equal to yung clock natin. The significant bit plus 1 is the placeholder for RS. Tapos LSB plus 2 is your read-write bit naman para dun sa ano natin. So, pwede natin tanggalin to. Port B na lang ilalagay. Okay. So, pag nakaset niyang ganyan, DRAM yung susulatan niya. So, any of these items here is considered to be a value that is written into the DRAM natin. Okay. So, kung ano yung character set na labas dyan, 31, 1. Pag in-enable ko to, magsusulat na siya. So, dito, sasabihin ko lang, 0x31 writes value of 1 on address 00H. Ang addressing kasi nito, ito yung address 0, address 1, address 2, address 3, address 4, so on and so forth. Pagdating dito sa susunod, I think this is a different system na dun sa addressing. Let's take a look. So, nasusulat naman yan dito eh. Ayan o. 40 yung second line niya. So, 40 yung gagamitin mo to get to that one. Okay? So, kunwari, gusto mong lumipat ng position. Okay? Kailangan magkaano ka, magka-character o magja-jump ka ng location. Okay? For that, kailangan mo instruction, hindi siya dataset. Okay? So, pag hinahin mo yung D7, that is already the impetus na yung ibibigay mo is actually going to be an instruction which deals with a memory location jump dun sa LCD. So makikita niyo dapat tong cursor na to, papatak siya dito if this is really 40. Okay? So, tingnan natin. Hmm. So, by the way, clock. Forget. Forgot that one. Okay, para mag-right siya. Tapos dito, ang sasabihin ko lang, 4T siya. Port B, CO, 0x CO. Jump to second line. First column. So pagka kinilik ko to, yun na siya. Tapos pwede na ako magsulat yan. Babalik ko lang to sa 1, tapos babalik ko to sa so i-clock ulit. Remember, any operation that has to do with this type of thing, may kulang pa ako. Port A 0 X 01 2 para maka-jump siya. Tapos babalik ulit ako sa kabila. Sasabihin ko port A 0x 041. Tapos sasabihin ko i-clock rin siya. Tapos dito sa susunod, babalik ko na naman to. One, two, tapos 0, 0. Wide, fine. So in essence, ito na yung program. So kakopy ko na lang siya, ipe-paste ko na lang siya dun sa micro C ko. So I'll make a new project, LCD demo. So tingnan natin kung magko-compile. Ay, sorry. I forgot the comment line. Control F9. Hey, F9. Void e-clock. Saan ba ito dapat? Sa ilalim o sa ibabaw? Anong kulang ko? Tama naman. Okay. So, void e-clock. Hmm. Ano mali? Did I miss anything? Tingnan natin kung nag-process siya na maayos. Close project. Close ko tong isa. Para sure full ako. Ito yung... Kita naman siya. But we have an issue dun sa kabilang side. Don't know what it is. Nandun naman siya sa ilalim. Sa Arduino kasi, kailangan nasa gitna siya. Hindi siya pa pwede sa ilalim. Weird. It's a weird problem. Undeclared. So, let's see. Function declaration. Mm, micro C. Baliktad niya. Let's put it at the front. Weird. Or maybe it looks similar to something kaya siya nag-error. Okay. So kaya siya nag-error. It looks similar to something. Okay. So now that this is done, okay, ang gagawin lang natin is to simply go into the Project Explorer, check the files natin, and try to find the missing. Nasa Python yun. So again, this is the quick way to to test it out kung okay o hindi. Plugins, this LCD display. Ah, baliktad siya. Okay. As you can see here, ERS. So yung E natin is at the third bit niya o bit 2. Okay. So kailangan natin tong palitan. Port A plus 4 dapat siya. Minus 4 dapat siya. Tapos itong isa yung 0 dapat yan. Ito 1 to. That should do. Okay. So, let's see. Kasi dun sa isa gumagana naman eh. LCD demo X. So, tingnan natin. Okay, nothing. Let's try another plugin. You know, one start. Ah, okay. So that's the reason why. Mali yung processor. Load ulit natin yung hex. So nakita mo may 1 dun. Pero again, this is a very rough estimation ng mismong progress natin, but it works to a certain degree. Meron ka lang kailangang hanapin. I don't know kung ano yung exemption error na nalabas dun sa system. Okay? So, ang maganda lang dun sa C, yung character set, you can write it out not as this one. Okay? Pwede mo sabihin na ganito lang. 1. Pwede mo sabihin na, sorry, yan. Pwede mo sabihin dito na yung 41 mo is A. Okay? Fine, save. Tinignan ko lang kung okay lahat. Reload natin. Reload natin yung binary. X, fine. Oop, sakita. A. Inalabas ngayon. Okay. So, yun yung mga pwede mong gawin pagdating dun sa isang site. So, again, this is not too much of a big deal pagdating dun sa because you're using micro C. But if you were going to use MPLAB IDE, this is going to be a very big pain in the ass itong isang to. Sorry, itong isang to. To get it right to like 4 milliseconds, it would take considerable amount of time and testing. This is again the reason why we have C compilers that we tend to use. So yun na. So I'll stop the record.